Hello everyone and welcome to our group presentation. Our group is called Triumvirate and we will be presenting about the application of geometry in our daily life. Without further ado, let's move on to our next slide. I will introduce you to our group members. They are, from left to right, Zarif, Izam, and me, Ashraf.
Hi, my name is Muhammad Zarif bin Roslan and other people call me Zarif. I live in Lenggong, Perak and my hobby is watching Netflix.
Hi, my name is Muhammad Ashraf bin Muhammad Nasir. I am from Rambau, Negeri Sembilan, and my hobby is reading.
Hi guys, my name is Nur Azlizam Haziman Analaki Salim. People call me Izam and I am from Hulu Selangor, Selangor and my hobby is playing badminton.
Hi guys, we continue with the application of geometry in architecture. There are many geometric influences in this field. Among the influences is the tower that my group chose, which is One World Trade Center. So let's get to know about this tower in the introduction to One World Trade Center. First, we start with the location of this tower. This tower is also known as Freedom Tower, is built on part of the land of the original complex in Lower Manhattan, New York, United States. The 104-story skyscraper is located in the northwest corner of the 6.5 acres it occupied the entire World Trade Center, on the side where stood the building 6 of the first complex. To the west is surrounded by West Street, on the north by Vesey Street, south on Fulton Street, and east by Washington Street. Next, we proceed with the history of this tower. One World Trade Center was built due to the destructions of the original World Trade Center due to the terrorist attacks on 11 September 2001. As you can see, on the right side is the original tower, which is World Trade Center, and on the left side is new tower, which is One World Trade Center. The design of this tower was designed by Daniel Lipskin in 2002. The final design for this tower was formally unveiled on June 28, 2005. The tower began construction in 2006 and was fully completed in 2013. The tower was first opened on November 3, 2014. We continue with the design of this tower. The tower is built with a height of 541.3 meters and has 3 parts, which are the base, the building, and the mass. The building stands on a concrete base, windowless, 56.69 tall, with a footprint of 61 meter by 61 meter. On the building part, from the 20th floor upwards, square edges cubic base of the tower are beveled inward, transforming the way the building into 8 tall isosceles triangles or form elongated antiprism. And the last part of the tower, a sculpted mast 124.3 meter holds the transmitting antenna. The antenna is secured by a system of cables and rises from a circular support rings contain additional dissemination equipment and maintenance. At night, it projects an intense beam of light above the tower, which is visible to more than 3,000 meters. And now, what problems can we make from this building? Let me show you. If you look at the One World Trade Center glass mirror, it looks like a mirror in a bathroom because it forms colors according to the reflections around it. Most of the pictures we found about this tower on the internet, the color of the glass mirror looks like blue because the reflections from the blue sky. Because of that, we intend to change the color of this glass mirror tower to a different color to make it look more newer and interesting. Is it impossible? Of course not. We can change the color of the glass mirror using a tinted film such as this silver gold film. However, there is a problem that we need to solve before we can put it on the glass mirror of the tower, which is how many rolls of tinted film is needed to cover the entire glass mirror and how much does it cost to buy the tinted film. So, let's solve this problem. To find out how many rolls of tinted film that we need to find the total surface area of the tower glass mirror. If you look at the tower, the glass mirror is on the building part, which is the middle part of the tower. For information, all the glass mirrors on the building are in the forms of 8 isosceles triangles. They are congruent to each other with 4 triangles facing down and 4 triangles facing up. Instead of finding the area of the triangle and then multiplying by 8 to get the total surface area of the glass mirror, we can also use a shape of parallelogram to find the total surface area of the glass mirror. The 8 triangles forms the parallelogram with the same height as the triangles and whose base is equal to 4 bases of the triangle. To find the area of this parallelogram, the formula is the base multiplied with the height. First, we need to find the height of this parallelogram. The height of this parallelogram is equal to the height of the building. We can get the height of the building by subtracting the height of the tower with the height of the mast and the height of the base. The height of the tower is 541.3 meter minus with the height of the mast and height of the base, which is 124.3 meter and 56.69 meter. So, the height of the building or the height of this parallelogram is equal to 360.31 meter. Next, we need to find the base of this parallelogram. To find the base of this parallelogram, first we need to find the base of the triangle. If you look at the tower, the length of the base of the triangle is equal to the length of the base footprint of this tower. As I explained in the introduction of this tower before, the site has a footprint of 61 by 61 meter, which means that the length and the width of the base footprint are the same. So, from this statement, we can identify that the base of the triangle is equal to 61 meter. To find the base of the parallelogram, we can clearly see that the base of the parallelogram is equal to the 4 bases of the triangle. So, the base of the parallelogram is equal to 61 meter multiplied by 4, which is equal to 244 meter. And now we can calculate the area of the parallelogram, which is area of the parallelogram equals to the base multiplied by the height, which is 244 meter times 360.31 meter equals to 87,915.64 square meters. The next step, to find out how many rolls of tinted film that we need to divide the area of the glass mirror by the area of the 1 roll of tinted film. According to our research on Shopee, we found a shop named Chris3200 that sells silver gold film with the largest size of 100 cm wide and 243 cm long at a price of 38 ringgit 45 cents per roll. So, the area of a roll tinted film in meters is 1 meter is multiplied by 2.43 meter equals to 2.43 square meter. So, the number of rolls of tinted film required is 87,915.64 2.4 square meter divided by 2.43 square meter equal to 36,179.2757 rolls. In counting, we cannot take decimal numbers and must take natural numbers. Therefore, the numbers of rolls of tinted film that we need is 36,180 rolls. Some must be wondering, why do we take 36,180 instead of 36,179? So the answer is 36,179 is still considered insufficient to cover the entire glass mirror surface compared to 36,180. Lastly, the total of numbers of rolls that we need must be multiplied by the price of a roll of tinted film to find out the total cost of expenses that need to be incurred to change the color of the glass mirrors of the tower. So, 36,180 rolls times 38 ringgit 45 cents equals 1,391,121 ringgit. So that's all for the application for geometry in architecture.
Hi guys, I'm Zarif. This is our second problem, jar of chocolate. So what's the matter? Last week, we will receive an order from a new company that's selling condom in different flavors of topping. They want to buy 10 jars of chocolate topping from our secret recipe. So this is their Instagram. I will show you our conversation. We just need 3 ingredients to make chocolate topping for our client. The first thing is hexagonal jar. This is 3 ringgit and 20 cents for each. We use 600 ml capacity jar. The second thing is olive cooking oil. This is 21 ringgit and 56 cents for 500 ml. And the important thing is chocolate bar. This is 6 ringgit and 85 cents for 160 gram. So how about details for each ingredient? For hexagonal jar, we buy the jar from Shopee. The price is affordable. It is 3 ringgit and 20 cents for each. The measure of dimension is 14.5 cm for height and 8 cm for diameter, like in the picture. For olive cooking oil, we also buy the olive oil from Shopee. The price is 21 ringgit and 56 cents a bottle. The bottle is 500 ml capacity. How about chocolate bar? We already have chocolate bar from our stocks. We use 160 gram chocolate bar. We got it with 6 ringgit and 85 cents. The measure of chocolate bar is 1.2 cm for height, 16 cm for length, and 8.5 cm for width. So, let's make some calculation for our client's chocolate topping. The first thing is we need to find the volume of a jar, but we need to find area the base of jar first. Area the base of a jar is 41.5692 cm square, and it will times with height of jar for get the volume. So the volume is 602.7534 cm cubic. For next, we will find the volume of chocolate bar. The chocolate bar volume is 163.2 cm cubic. We need to fill chocolate bar and olive cooking oil in the jar. But how much the ingredient we needed to fill in a jar? For the olive cooking oil, we just fill 1/4 from volume of jar. It is 150.6884 cm cubic, and the volume in milliliters is 150 ml. For the chocolate bar, we just minus volume of jar with volume of olive cooking oil, and we get 452.065 cm cubic. How many pieces of chocolate bar we need in a jar? We get 2 and 77 over 100 pieces. It is 443.2 gram. So, let's sum up all ingredients for all 10 jar. The total chocolate bar is 4422 gram. This value will divide by 160 gram. it is the value of weight for a chocolate bar. So we get 27 and 7 per 10 pieces. For olive cooking oil, we need 1500 milliliters. So we just need 3 bottles of olive cooking oil. Now the total cost. For the hexagonal jar, we just need 10 jar, right? So the total is 32 ringgit. For chocolate bar, we need 28 pieces. For the total is 191 ringgit and 80 cents. For olive cooking oil, we just need 3 bottles, right? So the total for 3 bottles is 64 ringgit and 68 cents. So the whole price is 288 ringgit and 48 cents. So done. Then we will send the total of cost their request of chocolate topping for their new condom lineup.
So we are nearing the end of our presentation. I will give you the conclusion. So the first thing that I need to tell you are geometry relates to measurements and properties of size, shape, and relative position of an object into a 3-dimension, including surface area and volume. It helps us solve particular problems involving angle measurements, length, height, and so on. Use a few formulas of distance, area, volume, such as Pythagorean theorem, area of circle, triangle, cylinder, volume of sphere, pyramid, and other solid shapes. In reality, in architecture, architects also use geometric principles in designing and construction, such as perfect living room perspective and skyscraper stability. Last few words. It helps us calculate the measurements of a shape. Therefore, it gives us the calculation and values that we are looking for with precision. That's all from us. Thank you for not skipping our video.